Let's go ahead and look at another flow rate adjustment problem. So we have an order for normal saline, 600 milliliters, IV to infuse in 5 hours, stat, which means immediately. Okay, so let's go ahead and calculate the initial pump setting in milliliters per hour. So remember, flow rate is equal to volume divided by time. Okay, so the volume of the infusion is 600 milliliters. The amount of time is 5 hours. All right, and you can punch that into your calculator. So 600 divided by 5 is equal to 120. Okay, so the initial pump setting in milliliters per hour is 120 milliliters per hour. Okay, so the second part of the question says, when the nurse checks this infusion 2 hours later, 330 milliliters are left in the bag. Recalculate the pump setting for the remaining 330 milliliters. Okay, so to answer this question, we want to ask ourselves, right, so how much time is remaining for this infusion, okay, after 2 hours? Okay, so remember the infusion was originally taking place over 5 hours. Okay, so 5 minus 2 is equal to 3. So there are 3 hours remaining for this infusion. Okay, so 3 hours are remaining. Okay, so to recalculate the pump setting, we're going to take the remaining volume, which is 330 milliliters, and then divide by the remaining time, so 330 milliliters divided by the remaining time of 3 hours. Okay, and you can punch that in your calculator, so 330 divided by 3 is equal to 110. So the flow rate, so in order for the infusion to be completed on time, to be completed within the time remaining, okay, we must make an adjustment down to 110 milliliters per hour from 120 milliliters per hour. Okay, so the initial rate was 120, so we're going to adjust it down to 110 milliliters per hour. Okay, so the last part of the question says, if facility protocols indicate that flow rate adjustments must not exceed 10% of the original rate, right, may the adjustment be made? Okay, so the question we want to ask ourselves is, right, what is 10% of the original setting, okay, or the original rate? So what is 10% of the original rate? Okay, so to figure that out, we're going to multiply 10% by the original setting of 120 milliliters per hour. So times, okay, 120 milliliters, okay, per hour. Okay, so remember 10% must be converted into a decimal, so 10 divided by 100. So 10 divided by 100 will give you 10% as a decimal, or you can take the number 10 and move the decimal point 2 places to the left to get 0.10 or 0.1. Okay, so 10% as a decimal is 0.10. We're going to multiply that by 120 milliliters per hour. Okay, so 0.10 multiplied by 120, okay, is equal to 12. Okay, so the maximum adjustment we can make is 12 milliliters per hour. Okay, according to the facility protocol. All right, and keep in mind that the maximum adjustment, right, it will depend okay, on the original setting, okay, and the facility protocols that indicate the percentage that adjustment rates can be made. Okay, so in this problem, right, is 12 milliliters per hour, okay, is the maximum allowable, okay, adjustment, okay, we can make for this infusion. Okay, so like we did with the previous example, right? So what was the difference between the original setting and the new setting, right? So the difference, okay, between the original setting and the new setting, okay, is 120 minus. So in this case, we're taking the larger number, okay, which was the original rate, and then subtracting from it the new rate, which is smaller, okay. Okay, so which is 120 minus 110, okay, which is equal to okay, which is equal to 10 milliliters per hour. Okay, so since that adjustment is within the maximum of 12, okay, it is okay to make the adjustment. So since the adjustment, okay, is less than, right? So it says must not exceed, right? Must not exceed means less than or equal to. So since the adjustment is less than 10% of the original, okay, flow rate, okay, the adjustment is okay. Okay, and that completes this example on flow rate adjustments. So remember, you're going to do a similar process when you answer this particular question in the homework. Okay, so the next couple of examples involve calculating the volume that will infuse over a given period of time. Okay, so the first example I have here is a continuous IV is infusing at 40 milliliters per hour. And the question is, how many milliliters will infuse in 30 minutes? Okay, so in other words, 30 minutes, okay, is equal to how many milliliters? Okay, that's what the problem is asking. Okay, and notice that the units of minutes, okay, for the given amount of time, all right, is incompatible with the units for the flow rate, which is given as milliliters per hour. Okay, so it's fine that the flow rate is expressed in milliliters per hour. Okay, but the fact that it's expressed per hour, right, means that it's incompatible with the units that are given for the amount of time, which is in minutes. Okay, so what we need to do then is convert 30 minutes into hours. Okay, that's a quick calculation. Okay, I'll go through it slowly. But essentially what you're going to do is you're going to multiply by 1 hour over 60 minutes. Okay, so essentially you're going to take the number of minutes, okay, if the amount of time is given in minutes, so divide the number of minutes by 60, okay, to get the number of hours. Okay, so in this case we're doing 30 minutes divided by 60 minutes. And you can probably do that in your head, but I'll do it on the calculator. Okay, so 30 divided by 60 is equal to 0.5 or 1/2. So you may have already known that 30 minutes is equal to half an hour. So it's equal to 0.5 or 1/2 of an hour. Okay, so now that we have the amount of time in hours, okay, that makes it compatible with the units for the flow rate, which is milliliters per hour. Okay, so we're going to take the half an hour and multiply by the flow rate of 40 milliliters per hour. So 40 mLs over 1 hour. Okay, so per hour means per 1 hour. Okay, so over 1 hour. Okay, so the units of hours cancel, and you're left with the units of milliliters, which is what we want. So it's the amount of the solution that's going to infuse over 30 minutes. So 0.5 times 40 on your calculator is equal to 20. Okay, so over half an hour, right, 20 milliliters of the solution will infuse. So the answer is 20 milliliters. Okay, let's look at the next example, and it says, how many milliliters of D5W, so it means dextrose in water, and the 5 means that this 5% solution of dextrose in water, will infuse intravenously in 10 hours at the rate of 13 drops a minute. Again, it says that the drop factor is 15 drops per milliliter. Okay, so you can see that the rate of infusion, the flow rate, is given in drops per minute. So we would not be able to answer this question without the drop factor. Okay, so if the drop factor was not given to us, right, we would not be able to answer the question. Right, so whenever the rate is given in drops per minute for this type of question, right, you must also be given the drop factor. Okay, so we're asked to convert 10 hours into the number of milliliters that will infuse. Okay, over 10 hours. Okay, so as you can see, the given amount of time, which is in hours, is incompatible with the flow rate in drops per minute. Okay, so one thing we can do is convert the hours into minutes. Okay, so again, that's easy to do. Right, so you know that there are 60 minutes in 1 hour. Okay, so you're going to multiply by 60 minutes over 1 hour. Okay, so the units of hours are going to cancel. So 10 times 60. Okay, put that in your calculator or do that in your head. So 10 times 60 is 600. Oops. Right, 10 times 60 is equal to 600. So 10 hours is equal to 600 minutes. Okay, so now we're going to take that amount of time in minutes, all right, and multiply by the flow rate of 13 drops per minute. Okay, so multiply by 13 drops per minute, so the units of minutes are canceled. Okay, and that gives us the number of drops, okay, that are infused over the 10-hour period. So 10 hours is 600 minutes. So in the course of 600 minutes, okay, we are going to infuse 7,800 drops. Okay, so 600 times 13 is 7,800. Okay, but we want the answer in milliliters, right? We want the volume in milliliters. Okay, so we're going to take that 7,800 drops, okay, and knowing that there are 15 drops per milliliter, okay, we're gonna invert that, right? So that the 1 milliliter is on top. Okay, so per milliliter means per 1 milliliter. Okay, so the milliliters are on top, and then the 15 drops are in the denominator of that fraction. Okay, so that we cancel out the units of drops in the process. So essentially what we're going to do is we're going to divide 7,800 by 15 to get the number of milliliters. So 7,800 divided by 15. Okay, we may need to round that. In this case, we don't. So it's equal to 520 milliliters. So 520 milliliters, all right, will infuse in 10 hours.